Hello everyone, in this video we are going to discuss this problem which is the JEE Main's rank decider problem. Okay, and this problem is constructed with 4 chapters. Okay, just in case if you have not completed entire math syllabus of 11th and 12th. Okay, first chapter is matrices, second chapter is definite integration, third chapter is differential equation, and fourth chapter is your basically complex numbers. Okay, sorry, limits, not complex number, limits, and fifth chapter is complex number. Okay, now let us see how we can solve this problem. But if you in case have completed these 5 chapters, let me list them out. Okay, for reference, chapters are matrices. Let me rank them class wise. First one is complex numbers. Second chapter is limits. Third chapter is matrices. Fourth chapter is definite integration. Definite integration. And fifth chapter is basically differential equations. Okay, so differential equations. So if you are in such a situation where you have completed all these chapters, then you should definitely try this problem. Okay, if you have not completed any of these chapter, then once you complete, then try this problem out. It's going to be a really interesting problem. Okay, so now let us start with this problem. Now this problem says that let J be 0 1 minus 1 0 and I be 1 0 0 1, which is the 2 cross 2 identity matrix. For any real number x, let a matrix M be defined as limit n tends to infinity I plus x by n j whole power n. Let f of x equal to half of trace of m, where trace of m denotes the trace of matrix m. This is a standard thing. Okay, no new thing. Let y is equal to g of x be the solution to the differential equation, and they have given a differential equation here where x belongs to minus pi by 2 to pi by 2. Okay, and it satisfies this initial condition g of 0 is 1, and if I naught is defined as this big equation, and they are asking you to find out 100 by pi I naught. Okay, so if you see, this entire question is centered around this f of x only. Without f of x you can't find g of x, and without f of x and g of x you cannot solve this I naught. So we have to start finding out what is fx, right? So now let us see how we can do it. Okay, now if you see I plus x, now x by n j. Okay, now let me name it as a n. Okay, let me name it as a n. Okay, now here the a n is going to be I plus x by n j. Okay, now if you see, if I write the matrix over here, then we'll get 1 0 1 0 0 1, and there will be a plus followed by j has 0 1 minus 1 0, so you'll have something like 0, and this is a constant, so you'll have x by n, and here you'll have minus x by n, and here you'll have 0. So this sum is going to give you 1 x by n minus x by n and 1. Okay, so this is basically your a n. Okay, a subscript n. Now this is the part of matrix. Okay, now what we are going to use, we are going to use complex number over here. How? Let us see. Now let me store this an and remove this one. Okay, yeah. Now if you see, this is in the form of orthogonal matrix, but exactly this is not orthogonal matrix. Okay, this is just in a form. Okay, now what we are going to do is that we are going to take x by n as tan theta, x by n as tan theta, and when it comes to r, which is the modulus, we will take something like this, 1 plus x by n square. Okay, simply what I'm doing is I'm representing in the polar form, that's it. Okay, so if you know complex numbers, you should know all these things. Okay, they are very important. So you'll have 1 plus x by n whole square. Okay, and if you substitute this tan theta over here, if you simplify, you'll get secant theta. Okay, now what we are going to do is that we are going to substitute x by n as tan theta, so we'll get 1 plus, not 1 plus, 1 tan theta, which can be written as sin theta by cos theta. Just to save time, I will write it as s by c, and this will be minus s by c, and this will be 1. If I remove 1 by cos, then you'll get secant theta over here. Let me write as 1 by c itself, 1 by c, and here you'll get c, you'll get s, you'll get minus s, you'll get c, and 1 by c is just secant theta, and secant theta is equal to r, so we are going to place over here as r times cs, let me write it as cos theta, sin theta, and minus sin theta, and finally cos theta. Okay, so this is your matrix an. Now if you see in the question, they are powering this to n, so that's why what we are going to do is that we are going to write an power n, an whole power n. So if I do this, what will happen? An whole power n, and this is equal to r power n, and here you will get cos theta. Okay, cos theta, sin theta, minus sin theta, and cos theta, and this will be powered to n. Now we know that using de Moivre's theorem, okay, if we are powering cos theta to n, then we can write it as cos n theta. Now this is a property of complex number from the theorem de Moivre. Okay, now if you write cos power n theta, then this can be written as cos n theta. Okay, so this is actually a theorem which comes from de Moivre in complex numbers, so that theorem we are going to use over here. Okay, now if I use that theorem over here, you will get r power n cos n theta, then you will get sin theta. Okay, then you will get minus sin theta, minus sin n theta. Okay, sin of n theta, cos of n theta, minus sin of n theta, and you will get finally cos of theta. Okay, cos of n theta. Okay, so this is actually your an whole power n. Okay, now what we are going to do, we are going to apply limits over here. Okay, we are going to apply limits over here, and if you apply limits, then what will happen? If like n equal to infinity, let us see, that will be your m. Now if you see, r is actually 1 plus x by n whole square. Now if you make n tending to infinity, let me write it over here. Okay, let me write in next page for better clarity. Okay, when n tends to infinity, r power n will be 1 plus x by infinity whole square. Okay, let me write as tends to infinity whole square, and if we have something by infinity, 1 by infinity, then we can replace it 0, so this is going to be 1. Okay, and your cos theta, sorry, cos n theta and sin n theta will remain same. We are not going to replace it now. Since r power n is 1, so we can write a m as limit. I can write as lt n tends to infinity cos theta, sorry, cos n theta. Then we can write it as sin n theta. Okay, sin n theta. Then we can write it as minus sin n theta. Then we can write it as cos theta. Okay, so cos n theta. So this will be your m. Now we know that x by n can be written as tan theta, right? Because we assigned this in the initial step, right? So this implies that theta is equal to tan inverse x by n, and this implies n theta is equal to n tan inverse x by n. Okay, so I think it is a bit messy, so let me write in next page. Okay, so basically your n theta is going to be n times tan inverse x by n. Okay, now if I take n as infinity, okay, now this is just a small manipulation. Okay, now if I take n as tending to infinity, then what will happen is that your n theta is going to be limit of n tending to infinity tan inverse x by n, and here I'm going to write it as 1 by n, and to satisfy the standard limits we are going to multiply and divide by x, and we can see one thing that this is actually a standard limit, and this will be equal to 1. Okay, since this is equal to 1, so this is going to be our x. So finally what will happen is that if we take this limit, so if we take the matrix m, finally we will get to know that m is equal to cos x sin x minus sin x and cos x. Okay, so this is your limit m, and so this is the first task of the problem. Now they are saying f of x is half of trace of m. Okay, now we know that trace of m is nothing but sum of the diagonals which start from upper left to lower right. Okay, so if I write f of x as half times of trace of m, so this is going to be half of 2 cos x, which is going to be cos x. So finally your f of x is going to be cos x. Okay, so this is the second task which is over. Now if you know f of x, you will find out g of x easily. Now they are saying that g of x is the solution of this differential equation, so let me copy paste this. Okay, let me copy paste this differential equation, and yeah, so I copy pasted it. Now we know f of x is cos x, so knowing that we can write the solution of the differential equation. We know that this is going to be linear differential equation. Okay, if you read the chapter differential equation thoroughly, and the approach to solve such problem is that if this is p of x, let me write as p itself, and this is q of x, this entire thing, then the solution is given as y into y into e power integral p dx. If the independent variable is x, then it is y e power integral p dx is equal to integral of e integral of p dx, then multiplied by q dx and followed by an arbitrary constant c, and this e power integral p dx is actually your integrate factor. Okay, so if you know this thing, then we will apply it over here. Okay, now how we can apply, let us see. Now let me calculate if separately, which is the integration factor. Okay, so if is equal to e power p dx, and p is your tan x. Okay, since there's a y over here, must not take y, so e power integral tan x dx. Okay, and if you know the direct formula, you can write it as e power ln secant x. If you don't know, then approach is very straightforward. You can write tan as s by c sin by cos dx, and we know that if you differentiate cos, you will get minus sign, so this can be written as minus of differential of cos x by cos x, and this is a very simple standard case of dx by x, so this can be written as ln x, and if you have a minus over here, then it will become ln 1 by x, and here the x is cos x. Okay, if I take dt by t, then it will be ln t, and if there's a minus over here, then it will be ln of 1 by t, and t is cos x, so 1 by t is secant x. Okay, so I think that's very simple. I hope you know that. Okay, let me write it for reference as well. So this is going to be e power ln secant x, and if you use logarithm properties, e power log of e times something, so that is going to be the same thing only. So this is secant x. Okay, and let me write the small derivation of integral of tan x. So integral of tan x dx is equal to integral of tan x dx is equal to integral of sin x, okay, by cos x into dx, and sin x dx can be written as minus d times d of cos x, okay, by cos x. Okay, now let me explain this step from second step to third step. Okay, now we know that d by dx of cos x is equal to minus sin x, so this implies d of cos x is equal to minus sin x dx, and if you place this minus from RHS to LHS, you'll get the one which you have written in the conversion from second to third. Okay, so this is what I have written in the numerator, and if you say this is in the form of dt by t, so you can write this as minus of ln cos x, and generally we write mod over here. Okay, and if you place this minus inside, you will get to know it as ln secant x. Okay, ln mod secant x. Okay, and if you see, they are saying that x should belong from minus pi by 2 to pi by 2, if you have noticed the question. So in this question, mod is not required, but in generally you have to mention the mod. Okay, so this is integral of tan x dx. I have shown you the derivation. Okay, but this is something you have to remember it. If you don't remember, just remember this derivation, and you have to derive it in lightning speed. Okay, in exam. So the integration factor is secant x, and let me substitute in this first one. So we have y secant x, y times secant x is equal to integral factor which is secant x. Okay, integral factor which is secant x, integral factor which is secant x, and q which is your f of x square, which is cos x square, cos square x. Okay, cos of x whole square. Okay, so cos of x whole square or cos square x, and finally you will have something like e power sin x. So you'll have e power sin x and followed by dx and finally plus c. Okay, now if you see secant x into cos x is 1, so you'll have a cos x remaining, then you'll have e power sin x, then you'll have dx and you will have a plus c. Now if you see clearly there is a kind of chain rule that is applied. Okay, this is just the reverse process of chain rule. What we are going to do is that we are going to replace cos x dx as d of sin x. Okay, logic is same when I derive the integral of tan x. Okay, if I take this cos x dx, this can be written as d of sin x. Okay, this can be written as d of sin x. So that's why e power sin x, e power sin x times d of sin x and plus c. Okay, now we have e power t dt, which can be directly written as e power t. So hence y secant x is equal to e power sin x plus c. Okay, so y of secant x is equal to e power sin x plus c. Now if you see the initial condition, it says that g of 0 is 1, meaning if I substitute x as 0, then y should be 1. So if I keep x as 0 and y as 1, this implies y of secant x, which is 1 times secant 0 is also 1, and this should be equal to e power sin x. Now sin 0 is 0 and e power 0 is 1 and 1 plus c, which indicates that c should be 0. So hence y is equal to cos x e power sin x. Okay, cos x e power sin x. So this is your y, which is nothing but g of x. Okay, so if I replace this as g of x, then this is going to be a g of x. Okay, g of x. We know that f of x is cos x, right? And using these two information, we are going to solve the value of I naught. Okay, now let me copy paste the I naught as well. Okay, so I naught. Okay, page is over. Okay, so this is your I naught, and we know that g of x is cos x e power sin x and fx is cos x. So if I substitute over here, then you will get minus a, and let me keep a as pi by 2, so it is going to be minus a2 plus a. Okay, minus a2 plus a, and g of x is cos x e power sin x, cos x e power sin x, and f of x is again cos x, and there is an already e power minus sin x as well. Okay, e power minus sin x by 1 plus 27 power x, 1 plus 27 power x plus x cube cos x dx. Okay, x cube cos x dx. Now if I apply the King's rule to the second term, which is this one, you will see that this is going to be 0 because x power cube is an odd function and cos x is an even function, and hence this entire term is going to be 0, which is this term. Okay, so this entire term is going to be 0, and if I cancel out this e power sin x and e power minus sin x, okay, then you will be left with cos square x minus a integral of minus a2 plus a minus a2 plus a cos square x by 1 plus 27 power x dx. Okay, so this is your I naught. This is your I naught, and we also know that if you apply King's rule again, then this is I think a very standard case. You must have seen this before as well. It's a very popular one, not new thing. In many PYQs the same trend has appeared, where they will place an e power x or some number power x, and the limits will be of the form minus something to plus the same thing. So this is same thing. Okay, if I apply King's rule again, you will get I naught as minus a to a followed by cos square of. Now if you apply King's rule, then a plus b, right? Upper limit plus lower limit is going to be 0, right? I hope you know King's rule. Let me write again. Let me write once for you. So a b f of x dx is equal to integral a b f of a plus b minus x and followed by dx. Okay, so this is actually a King's rule. I am applying the same King's rule here only. Okay, I am applying the same King's rule here only. Okay, so if I apply the same King's rule, you will get lower limit as plus upper limit is 0, and 0 minus x is minus x, and the cos of minus x is cos x, and the whole square is going to give same cos square x. And if you have a minus x over here, if you have a plus of minus a minus x, you will have here 1 plus 27 of minus x power minus x, and this is with dx. And if you take LCM in the denominator, you will get 1 27 power x. Let me write it once. Okay, okay, so if I take LCM in the denominator, you will get something like minus a2 plus a cos square x by 1 plus 1 by 27 x power x and multiplied with dx. Now if you take LCM and take these denominator to the numerator, you will get something like this: minus a2 plus a integral and 27 power x plus 1 or 1 plus 27 power x, both are same thing. So I will write it as 1 plus 27 power x, and here you will get 27 power x into cos square x, and you will have a dx over here, and this is your I naught. Okay, now if you see, if I add equation 2 and equation 1, which is this one, if I add equation 2 plus equation 1, then one thing is very clear that, okay, equation 1 plus equation 2, just in case if you are missing in this track, then ensure that you check out the PDF of this session. You will get in description. So if you add 1 plus 2, equation 1 plus equation 2, you will get 2 I naught as integral of minus a to a 1 plus 27 power x times cos square x divided by 1 plus 27 power x dx. And if you see that the numerator and denominator cancels, Okay, so that is the power of King's rule. So you will be only left with minus a to a, and you will get cos square x dx. Okay, cos square x dx, and this is your 2 I naught. And if you see cos square x is even function, so you can write this directly as 2 times 0 to a, and this is your pi by 2. Okay, this is your pi by 2 cos square x dx, and this is your 2 times I naught. Now if I cancel these 2 on both sides, you will be left with I naught as you will be left with I naught as integral of 0 to pi by 2 cos square x dx. Okay, now here you can either use Wallis theorem or you can again use King's rule as well. Okay, now whichever you wish, you use it. Okay, now I'm going to use King's rule over here. Okay, now if you use King's rule over here, then you will get I naught as 0 to pi by 2, and pi by 2 plus 0 minus x will be pi by 2 minus x, and cos of pi by 2 minus x will be sin x. It can be either plus minus sin x because x is between minus pi by 2 to pi by 2. So cos of pi by 2 minus x can be plus sin x or minus sin x, but since we are squaring it, so it is going to be sin square x. Here we will not have plus minus tension. Okay, so we will have finally sin square x dx, and if you add this, you will get 2 I naught as 0 to pi by 2 1 dx, and if you substitute it directly, you will get it as pi by 2. Okay, and this implies I naught is equal to pi by 4. Okay, so finally we got the answer of I naught. And if you see the question is asking you to find out 100 by pi I naught. Okay, 100 by pi I naught. So 100 by pi divided by pi I naught is equal to 100 by pi, and I naught is your pi by 4, and if I cancel the pi, and if you divide 100 and 4, you will get the answer as 25. So the final answer for this huge question is 25. Okay, this is a numerical question, no options are given. Okay, to ensure you do not guess any option. Okay, and this is the final answer of the question. If you see, approach is too long, so that's why this is a rank decider problem. Okay, why it is a rank decider problem? Because it does not only test your knowledge, it also tests how fast you're able to execute all these things. Okay, see, if you see, I have spent 18 slides to derive the answer, right? So that's why this is a very good rank deciding problem. So make sure that you practice these kinds of problems so that you will get a very good rank in your JEE Mains because of Mech. Okay, so I hope you understood the solution. And just in case if you have completed all these 5 chapters which I was mentioned earlier, then please do come and solve this problem. Okay, this is a very good problem. Okay, so if you're in such a situation who didn't complete any of these 5 chapters, then please save this video, and later on when you complete everything, do definitely solve this problem. This will really help you a lot. So finally, that's the end for this video, and we'll see you in the next video. Until then, all the best for your preparation.